This video is brought to you by makeITsimpleTT, the premier online learning space for CSEC IT and computer science classes in the Caribbean. All our classes are run on the familiar and secure Google Classroom platform. The weekly videos are well laid out and labeled by topic, dated, and placed in reverse chronological order to ensure easy access even if you miss a class. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799. Okay, so as I was saying, today we are going to be doing the repetition and control structure. So let's jump in. I jump into it one time now. No time to wait. So looping, iteration, repetition, control. What does it mean? All right. So there are three control structures, as you should know by now. The three control structures are sequential, selection, and the next one is loops or looping. I would have dealt with sequential in video 2. I would have dealt with selection in video 3, and now we are on video 4, which we're dealing with loops, right? So we're going through loops, and the point of loops would be that you want to repeat something. That's why you'll see the words either repetition or iteration. Iteration is a big word for iterate, repeat something over and over. Repetition is another word for repeating something over and over. And looping is another word to do that, right? Now there are three major loops. There's the repeat until, which is the easiest one to understand because our brains are wired to repeat something until something happens, which is like, keep asking for something until they give it to you, or keep bothering somebody until they give in, or something like that. Then you have while. While is a little easier, a little harder to grasp, because we say, while this is going on, do this, or while you are waiting, do that, or while something is happening, do this, right? So that one, okay. And then there's the for loop, which is for something is a start value to end value, do. This one is the most computerized one of them all. The for loop is the easiest one to follow, so that's why we'll be doing the first one. The first one I will be doing is the for loop. So just to give you an example of what a loop looks like, it looks like this. So that would have kept going on as long as I decided to keep it going on. So I created a loop and I stopped it when I wanted to. And that's the whole point of a loop. So there are two types of loops. The first type of loop is called a definite loop. A definite loop means that you don't know where the boundaries are. The boundaries of the loop are set. No, you know where the boundaries are. Sorry, a definite loop, you know where the boundaries are and they can't be changed. So if I tell you run 5 laps, you know that you have to run lap 1, 2, 3, 4, 5. If I tell you drink 10 gallons of water, you have to drink from 1 gallon of water to 10 gallons of water. That's a definite loop, and you will keep going until you reach the cutoff point. That's definite. We know how to stop it because we know where we're going to stop. An indefinite loop, however, says that the boundaries of the loop, they are not set, and the user determines how long it runs by the values they put in. Now these values are usually called variables, and the variables, they are put in something called a condition. Now, if you remember last video, we would have gone through conditions where there would have been a condition like if something something, then something something, right? So that means that you would make a choice. But a if condition kind of goes like this. You reach to this point and you either go left or you go right. But a loop condition means you keep doing this thing over and over and over, and the choice is really made here. And based on the choice, you will keep looping, looping, looping. And once the loop stops, then you'll be able to go to another branch. So with a if, there is literally just two options. With a loop, there is one branch that goes to some other option, but then there's one that keeps repeating. So let's go through what the definite loops look like and the indefinite loops look like. Definite loops would be there's a start and there's an end. I know where I'm starting, I know where I'm ending. If I have to run a marathon, I have to run 26 point something miles. 26 miles, I think. So you know where the start is and you know where the finish is. If I have to run until I'm tired, you don't know where that is. For some people, running until they're tired will be 100 meters. For some people, it will be 1,000 meters. For some people, it will be 26 miles. For some people, it might be 45 miles. But we don't know. But the process of running keeps going on and 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 on until the condition of, all right, a bun is reached, right? So you need to kind of keep that in mind. So let's go. First loop is called a for loop, or do. For something to something, do. That means that what you are going to be doing is you're going to say, all right, I'm going to start and create a variable called counter and tell this counter start at a particular number. So I can tell the counter start at 1 and then go to the end number, which is 10. That means whatever is between the words for and end for will be considered as the things that I want to do 10 times. What will be the things that I want to do 10 times? That's this box inside here. This box inside here will have all the statements that I want to run 10 times. So I could say for counter is 1 to 10, make a pastel. For those of you who know what a pastel is, there's a lot of things I have to do to make the pastel. You have to make the meat, and you have to make the cornmeal, and you have to take the fig leaf, and then you have to put the fig leaf on the fire, and then you have to put it in, and then you have to boil it. All those are steps. So if I have to make 10 pastels, I would follow the steps that are necessary 10 times to make the 10 pastels every single time. That's if you're making one at a time, but it would be kind of dumb to make one pastel at a time. Unless you're like experimenting or something. But the point is, whatever is between the words for and end for will be repeated the amount of times that you have to go through. So you see the 1 to 10 here, it could do that. Now a for loop could even go from 2 to 7. Doesn't matter. It could go from 11 to 31. Doesn't matter. The point is you know where you're starting and you know where you're ending. This is called a definite loop because we know that there is a start and there is an end. That's what makes a for loop, right? So let's look at this example here. This is pseudocode to print the word "this is a loop" 5 times on the screen. So let's assume there's a computer screen here. This is the computer screen. And the computer screen is going to follow our instructions, which is for counter is 1, 2, 5, do. So how many times is this thing trying to run? It's trying to run 5 times. You can imagine that when you write a for loop, it's trying to do something like this. It's trying to go 1, 2, 3, 4, then 5. So you're going to try to follow this kind of arc to get from 1 to 5. Each time, whatever is between the words for and end for is going to be printed or going to be run or whatever it is. It could be addition, it could be subtraction, it could be calculating the mass of the sun. Doesn't matter. Once it's between the for and end for, it will go through the loop. This is how we get computers to simulate humans as best as possible, because as humans we go through a lot of loops, a lot of procedures in order to get things done. Because walking by itself, like moving your foot back and forth, that is a loop, but we don't ever think about it like that. A computer can't do that on its own, so we have to create a framework for the computer to be able to do this loop, right? So let's go print. This is a loop. So what will happen is the first time the loop runs, I'll just put the 1 on the outside here. First time the loop runs, it will say this is a loop. Cool. The end for will go back up and be like, okay, what number we reach now? Okay, we're down at 1. We now on 2. What do I have to do the second time? Put this is a loop. Cool. The end 4 will say, okay, where we reach. The 4 will check now and say, okay, we finished with 2. Now let's move on to 3. What is going to be printed now? This is a loop. And then the end 4 will do it again. Alright, I've done my part. What else happens? The 4 will now say, alright, we just finished with 3, now we're on 4. Okay, what is the 4th thing that will happen? This is a loop. This would not come in handy when you had lines to write in school, but anyhow, I don't know if teachers will still do that. Just giving lines in school anymore. Then it'll go for a 5th time and put the words, this is a loop. Now, the good thing about a for loop is that you know when it's going to start and finish, and it's going to do exactly what's inside here. So you could kind of predict what is going to happen because you could see it. You could count it. You could predict it because you know when it's going to start and stop. However, the other loops, you can't predict when it's going to start and stop because it depends on a user. So let's go to let's do some simple questions now. I will do the I'll do number 3, right? So I'll do number 3. Number 3 says you have to write a loop to get their names and ages. I can't remember how much people, but 10 people, I guess. So we will write, I'm not writing the whole algorithm for space purposes, right? So I'll just go from start and stop. But normally I'll have to declare variables and stuff, right? So I'm going to start with start for C, which is for counter, is equal to 1, 2, 10, do. I want to get somebody's name and their age. So my statements that I need to do would be print, enter your name and age. If my handwriting is trash, it's because my handwriting is trash. I normally type these things, but you know, sometimes I write, sometimes I type. And then you have print, enter your name and age, and then we read name and age. Ta-da! And then we say end for, and then stop. The reason why we have to put end for is we have to let the computer know that here is the end of the whole construction that we have created to let you know what you have to say. What do I want you to do? This is what I want you to do. The things that are in this box here, I want you to do that 1, 2, 10 times. And that's basically how a for loop works. It could get very complex based on the things that you put inside the for loop, but once you know how much time something is supposed to run, all you have to do is set the number up and then know what you want to do and make sure it's between 4 and N4, and then your algorithm The algorithm is cake there. Right. Any questions from the adoring 7 fans that we have online right now? No? None? Great. What, Ren, were you laughing at it? I didn't tell any joke. I don't think I was funny. But if you do think I was funny, oh wait, I really laugh. I'm not too sure. Let me think about it. Alright, no questions, right? All you like the 4 people of y'all who here to learn. Do you have any questions? No responses.
Did I stutter?
Right, okay, cool. Oh, my handwriting. Yeah, my handwriting is trash. Right. Yeah. Okay, so let's go. Next loop now that we're going to work with is called a while loop. So a while loop is based on a condition. Just like how a if was, a if is based on a condition, but a while loop now, if the condition is true, what you are going to do is you're going to repeat a set of instructions as long as the condition is true. So just like with a if, you always check to see if the answer to this is yes or no. If the answer to it is yes, then do whatever is inside the list of instructions. If the answer to it is no, then you don't do what is inside the instructions. You ignore all of this and you move on to whatever line comes up next. That's what makes the difference between a for loop and a while loop. A while loop has a condition that you must check. So let's look at a simple example. Let's say I want to get a person to put in a number greater than 5. So I tell you, hey, put in a number, keep entering numbers, and I will stop when you put in a number that's greater than 5. So you ask Jenny to do that. Jenny decides to put in 3, 4, 2, 6. And I just say, like, you tell Jenny, okay, and give me some numbers. I'll stop when you enter a number greater than 5. Jenny decides to start with a 3. So let's trace through what the computer will do. The computer says, enter a number greater than 5. Cool, we accept the number greater than 5. Then we read the number. So in this case, the number that we're going to get is the first number here, which is a 3. So we read the 3. So we say 3 is less than 5. Now this is the condition part here. This is the condition. This is where you're going to have to make a choice. You're going to have to make a decision. Gosh, I'm now watching the chat there. The icons, I got a 1 in IT, thanks to you. Okay, you're welcome. Got a 1 in IT, just remember, any Sunday lives is with it, guys. So it's pure greatness. Alright, cool. You're welcome. Yeah, anytime. Don't mention. Tell it to the others. Right, so our condition, back to this. Our condition is while 3 is less than 5. Now the answer to this can either be yes or no. If the answer to it is yes, then we do this set of commands inside here. If the answer is no, then we just kind of ignore this command inside here and move on to something underneath after the end while. So let's check. Is 3 less than 5? The answer is yes. So then we will print out on the screen, this is not greater than 5. Because it is true, the number is 3. So then it's going to ask us to read a new number. When we read a new number, now the number 4 is going to go into the system. The number 4 now will be read, and then we're going back up to the while. So the job of the end while is to go back up and say, hey, while, what's the status? And while will be like, okay, the status is we now have a 4 that we compare to 5. Is 4 less than 5? The answer is yes. So because the answer is yes, it will print that is not greater than 5. So far, the algorithm doing the job it's supposed to do. It's supposed to say if the number is not greater than 5, tell them. And once the number is greater than 5, we'll just move on with life. So we reached the 4. Now the next thing that we're going to do now is to work with the 2, because we're going to read a new number. The 2 will come inside and we're going to say, is 2 less than 5? The answer is yes, 2 is less than 5. So therefore it will say that is not greater than 5. However, the loop now is going to reach a critical point where it's going to be while number is less than something. And the last number that we're going to get the number 6. Because the number 6 is there, we're going to say, okay, while 6 is less than 5. Is 6 less than 5? The answer to that question is no, it is not less than 5. So because it's not less than 5, the loop now is going to be like, hey, we can't continue because our condition says no. Once the condition says no, then tell yourself the loop is over, move on to whatever else you have to do. And that's how a while loop works. Now what you would realize is that the while loop is an indefinite loop. Okay, you can see the word indefinite right here. Indefinite. Because we don't know when it's going to stop. It depends on the user. Some users would put 3, 4, 2, 6, and some users would put 1, then 7. Once they put out 1 and 7, the 7 will automatically kick in and say, okay, the while loop's supposed to stop now. So that makes it indefinite. Indefinite loops are powerful because now you could give the user the choice of whether they want to stop the loop or not. Definite loops are for like if you want to control some sort of process. So let's look at our next example of a while loop. Next example of a while loop will be like this. We want, the name of this one is pseudocode, to keep getting numbers until 0 is entered. So I want to ask for a number over and over and over and over and over and over and over until they put in 0. If the person puts in 0, that's a signal that they want to stop. So that's kind of like you're going in under, I don't know, you're like holding your breath underwater or something. So, and they say, okay, raise your hand when you want to come up, and you hold it and you hold it and you hold it and you hold it and you hold it, and then you decide, okay, I'm done now, and then you raise your hand up. That is a sign. So there's a condition. The condition is if your hand is raised, take them out of the water. So that's the mindset you need to have with this. This video is brought to you by makeITsimpleTT. Our CAPE classes run on an 8-month cycle and covers everything in the CAPE IT and computer science syllabus with 10 years of past paper practice included. Students get assignments topically and reports are emailed to parents and guardians monthly or bi-monthly. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799. So watch this. We ask the user, okay, please enter number and 0 to stop. So we literally prompt the user and say, hey, user of this program, keep entering a number and 0 to stop. Now you will kind of see this in the real world where you have to put in information and then click next to go to the next screen. What you are doing is you are inside a while loop, and only when you press the next button, you'll jump out of that while loop and then go to something else, because the next will be like the trigger. In this case, 0 is the trigger, right? So we read the number, and now you're going to say while number is not equal to 0. So this here is called the condition. The condition here could either be a yes or a no. It could be either one of the two. Yes or no. So the condition will be like, okay, if the answer is yes, then I will go through the statements inside here, which is print, please enter a number and 0 to stop, and I read a new number. So let's assume Jill, our test person, Jill puts in 6, 3, 2, and then 0. What will happen is that the computer will get 6. 6 is not equal to 0. Okay, cool. Read a new number. So the 6 gets 3 not equal to 0, because the condition will now be like, is 3 not equal to 0? Yes, it's true. 2 not equal to 0? Yes, it's true. 0, is 0 not equal to 0? When we reach to that point now, the condition will say, wait, hold on, number not equal to 0. 0 is not equal to 0. Hold on, the answer is not yes anymore. The answer is no. And then you like the so hold up there. Yeah, when 0 is equal to 0, you'll be like, hold up, something's wrong here, right? Yeah, so that's what will happen. And yeah, so the while loop is like it's checking to see, okay, I'm going through my life normal, everything is cool, and then you'll be like, wait.
You've said some pretty shocking things here. Wait, hold up, wait a minute.
Because all the time the numbers were 6, 3, and 2, but now we get 0. So wait, hold on, the 0 not equal to 0, that condition is now a no. So once the condition says no, then you end off your loop and you move on to the rest of your life. That is literally what happened. So that's our while loop. So now let's go to an example question. Let me see if I can get a question here. Using a while loop collect. Alright, so let's do number 3. Since I did number 3 before, I'll do number 3 here. I can't work out all of the questions here, but I mean, these are some sample questions. You can try them if you want, but I'm just going to work out number 3 so that y'all will get an idea. And I'm not going to write this one because when somebody laughed at my handwriting, so I don't want to be laughed at again. Alright, no, just kidding. Using a while loop, collect a series of names and only stop if the user enters an X. So let's see how this will work out. So we want to start, and then you're going to what we're going to do after we start, we want to say print, please enter a name and X to stop. So I ask the user to enter a name, so I read the name, right? Read name. Now how am I going to control the process of reading the name over and over until I get an X? Well, add up our control structure in place. The control structure that I'm going to put in place is a while loop. I'm going to say while name is not equal to X. Now, if you're wondering what this statement means, let's go back to like video 2, and you realize that not equal to can be represented by a less than sign and a greater than sign. In some cases, and in some places, you might see not equal to being an exclamation mark and an equal sign. That's how they do it in C programming and in like other programming languages. But in an algorithm, you just want to like be neutral, because there are some programming languages that will do it that way, some programming languages that will not do it that way. So just do the not equal to, right? So while name is not equal to X, what do I want to do? Well, what I want to do is I want to ask the person to enter a name and X to stop, because obviously the name that I got was an X. So I'm literally going to be doing over the same process, which is print. Please enter your name on Excel stop, and then I'll read the name again. And this name is the same name that's here, is the same name that's there, is the same name that's there, is the same name that's there. It's just the name, variable for name. And then I'll say end while, and now this loop will go on for eternity as long as the person does not put in an X. Then I do stop, and that will be the while loop. So that'll be the answer for number 3. Now we move on to the easiest one of them all, which is repeat until. Repeat until is so basic because that's how we are wired to do things. We start a process and we don't stop until something happens. So we will dance until the song ends. We will eat until we are full. We will play game until we are, I don't know, no, people will just play games until, I don't know. Play games until your mother comes and takes off your PlayStation or your computer or something like that. So there are many repeats untils in life, but the point is you repeat a set of things over and over and over until a particular condition is met. And the condition, of course, could be a yes or no statement. Like the condition will always be yes, it is true, or no, it is not true. That's just how conditions work, right? So look at this example. So if we want to determine adult age, right? So I'm going to read the age. This is the statement I'm going to be repeating, or the instruction I'm going to be repeating over and over and over and over and over and over and over until the age that I get is greater than or equal to 18. So this will keep going over and over and over and over because all I'm doing is reading an age. So let's say Jenny now decides to put in 12, 14, 18. Jenny now, the first age that is put in will be 12. The question now will be, is 12 greater than or equal to 18? The answer is no. If the answer is no, then I go back up to repeat the process. Repeating the process now will now change the number that Jenny puts in. Jenny puts in a 14 now. All right, cool, Jenny. Thank you very much. But now 14 is not greater than or equal to 18, so we repeat it again. After you repeat it again, now the 14 is used up. Now we go to the 18. So the 18 is what is put in by Jenny. And Jenny puts in a 18. And guess what? 18 is greater than or equal to 18. Because it is equal to 18. So now the condition is no longer no. The condition is yes. And once the condition is yes, then the loop is done. Whatever comes after will be carried out. So how does it work? Let's do the same number 3. Repeat. Collect a series of names and only stop when the user enters an X. So watch this. I'm going to take this same algorithm here and I'm going to do it in a repeat until. So you would just do your same start and stop. This is the, so make sure I clear for this is the until version, right? Yeah. Why did I put $? Because I can. Yeah. So start. All you have to do now is say, okay, repeat. Repeat what? Please enter. I can just copy and paste it, you know. Yeah, I'll be lazy like that. Please enter name and X stop. So I do the repeat. Ta-da! Please enter the name and X stop. Then I read the name. Good. But now I have to put in the until part. The until part now will be until what? Until name is equal to X. But I want to stop when the person puts in a name as X. So I repeat until name is equal to X. And then stop. So it's a little longer with a while loop because you have to read the value before the while loop, but the repeat until, that is literally it there. And that's how you do a repeat until question. So that was the answer for number 3. Okay, so the last thing that we want to understand is something called infinite loop. When you're writing programs, infinite loops happen when the condition will never be met. So if a condition will never be met, you have a loop that's going on. So infinite loop. And that happens like when your phone sticks, it goes through an infinite loop. You see the loading circle going around and around and around and around. It's an infinite loop. Something is wrong and the program can't figure out what is happening because it's keep trying over and over and over, but the condition is never being met for it to move on. So an infinite loop will be like this. If I say while j is greater than 10, but every single time I go in the loop, I say j is equal to 11. I'm basically saying j will always be 11 when I go inside the loop. So when I check back, j will always be 11 is greater than 10. So if 11 is always greater than 10, then the loop will just keep going on because I'm purposefully setting j to 11 each time. If you want to harass somebody, you can literally give them this program and be like, just set j to 11, but check for it greater than 10. It will keep going on and on and on. This is how they make, like, programming bombs or hacker bomb. When you run the program, it'll just start to create files on your computer because you create an infinite loop. And if you create an infinite loop, you could be a bad person. but you could also be Doctor Strange. But we ain't gonna go too far. We ain't gonna go down that road. And right, so that's it for today. Those are the 3 loops. And next week, we're going to now start to take these loops and figure out how you could use them to your advantage to get things done. So now we know how to use sequential, we know how to use selection, and now we know how to use loops. If we put those 3 things together, we could get a computer to do things that we could simulate, sort of like human activity or human thought. And once we could get a computer to simulate those things, then we'll be able to start to write programs because we know how to tell a computer what to do. Because all of this is really to think, how do you tell a computer what to do? And that's what we're learning. Telling the computer what to do, you need to use sequential, selection, and loops. So next week, we'll start to apply the 3 of them into different questions, and you will see how they carry out their tasks, and you'll be able to understand how to make them work for you. This video is brought to you by makeITsimpleTT. Every class is structured to run on a yearly cycle from June to May. This cycle covers the whole syllabus in 12 months with 1 2-hour session per week, along with assignments that are given weekly. Every class is recorded so students can always go over the work and recap notes in case they miss a class. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799.